Atlantium is part of the work package 4 and it aims to treat the DBPs, but you choose to go through a preventive approach. Can you tell us more of how your technology works and what did you find?
The first thing that came to mind when we were asked to join this consortium was doing AOP, advanced oxidation, to treat the disinfection byproducts already generated. But then we thought, hey, but disinfection byproducts, why don't we deal with disinfection? Because that's what UV companies do. They do disinfection of water. In bacteria, you disinfect water from bacteria. So they can have two modes of life. One is the free-swimming bacterium, which is planktonic, and another one is the attached bacterium, which we call the biofilm, like the plaque we have on our teeth. So the biofilm, the attached one, they grow pretty slowly. Let's say every 2 hours, even more, while the planktonic ones, in lab optimal conditions, it could be like 20 minutes, just to have a scale. So we thought, okay, 2 hours is a pretty conservative estimation, it could be even more, but let's see what happens. If you stop chlorination for 2 hours and then continue the chlorination for, let's say, 30 minutes. So you have 2 hours off and half an hour on. So you have only 20% of the chlorine, 80% less. And now we have to follow what happens with the biofilm of the bacteria that are building up on the pipe. So that's what we measured. That's the idea, that you cut 80% of chlorine and get the same results in terms of attached biomass. Well, the results were that we thought that it's going to have some improvement, but actually it was the same result doing the periodic chlorination, and like 100% of the time the continuous chlorination was the same result.
The treatment with UV is known to have no residual disinfection, right? But the current regulations require this residual disinfection, usually with chlorine. How can this work in a real case scenario?
Okay, so we have like two problems here that you're pointing out. One is that the regulatory problem, and one is the bacteriological issue. So in terms of bacteriology, we just said that like the periodic chlorination is the same for the attached biomass, but for the planktonic biomass, you're gonna install UV ahead. So you have both UV and chlorine, but chlorine is only part of the time, so you have less disinfection byproducts. So that's the bacteriology part. But the regulatory thing is a problem. Like when we just heard that, yeah, the consortium got approved, oh man, now we have to make it work, but it can never work because the regulators, our idea is really nice on paper, but in the real world, the regulation would never approve of it. But then like my colleagues explained to me that Horizon is exactly the place you want to be if you want to let regulators hear of new ideas and think, I don't know, 5-10 years ahead. So when I realized that, I was very happy to start working.
How do these technologies compare in terms of performance, cost, environmental footprint, etc.?
Yeah, that's another thing I never understood before I joined this project. So one of the work packages projects was the life cycle analysis or cost, and what I learned from them is that when you have like a complete water treatment facility, the cost of the entire thing is so huge that when you look only on the disinfection process, it's a very small amount relatively, but still our idea is reducing chlorination actually improves, it cuts the price. Even if you install UV, you actually make the process cheaper, because apparently chlorine is much more expensive than I thought before.
And what specific problems or gaps are these solutions aiming to solve the current methods?
As far as I know, there's not really a lot of solutions to handle disinfection byproducts by chlorination. I heard of one option of volatilization by spraying the water in a tank. So that's one thing. It can definitely help against the volatile ones. I know that in food and beverage companies, where the flow rate is not that huge as municipal settings, they use activated carbon, which works. But I don't think that it's something that can be done in a scale of municipalities. Like, it can be done in terms of it's possible, but it's probably pretty expensive.
In your opinion, how important is it to act now on this problem rather in the future, or waiting for future regulations or market changes?
I think, well, when I'm looking only at my solution, which is pretty new, I think it's not right. It's not ready to do like a full scale. So I think that regulators should be aware of that and maybe say what they think about it. Like, what I would love to hear a regulator tell me what I need to do to make him believe in it. So either me or a different UV company or researcher will take it to the next step.
And on the flip side, what are the biggest barriers to adopt this technology? Are they technical, financial, regulatory? We already spoke about it.
Yeah, so the regulation, yeah, we discussed, but well, our way to prevent disinfection byproducts is related directly to chlorination. But you have disinfection byproducts with bromine and iodide. Our idea is not going to improve water quality for these ones at all. I was excited and enjoyed working in this project, and hoping to have another one